Hello, question 9, and I've done no prep for this. I've got it all set up on the Surface Pro, and I'm ready to just work my way through this one. Hopefully I get it done in 15 minutes. It's 11 marks, a big question. So use making food and drink cans in the prelim material, which I've got over here on this side. A food company is making a new soup product. The soup will be put into a new size of can. In a trial run, the food company produced between 1900 and 2150 litres of soup per hour. The company manager asks a can manufacturer to supply 3-piece cans with diameter 7 centimeters and a height of 9 centimeters. The can manufacturer must buy 1 by 1 meter sheets of steel to make the cans. Estimate how many sheets of steel the can manufacturer will need to make enough. Let me read that again. Estimate how many sheets of steel the can manufacturer will need to make enough cans for 1 week of soup consumption or soup production. Give the answers to the nearest 10 sheets. That's going to be a big number. State the assumptions, and you must show you're working. Okay, so, right. Let me just get back to my actual pen and write that down. So it's 1 week. 1 week of cans. 1 week. We've got 1900 to 2150 per hour. Okay, so there's going to be an assumption about that. Let's have a look at the rest of this. So the basic material used for most food cans in the UK is steel. There are 2 ways to produce the food cans: by using 3 pieces of metal or by using 2. So that's irrelevant. We want the 3-piece. The traditional method is to use 3-piece cans. This involves cutting pieces from 1 by 1 sheets of steel, and in most cases coating them on the inside with lacquer to protect the food inside the can. That's not really relevant. Rectangles of steel are cut and curled into the cylinder, and the edges welded together. Circular cans are also cut. The bottom end is seamed into the cylinder together with a compound that ensures an airtight seal. The waste steel left after cutting out the cylinders or circles is recycled for other uses. To make 2-piece cans irrelevant, both types of can are then sent to the company which ordered them to be filled with food or drink. The circular top of each can is then seamed on and treated to be airtight. Food and drinks cans can be made in many different sizes. For example, this 3-piece can has a radius of, right, so that's quite useful actually. Have we got anything on here? Diameter of 7, okay. Height of 9, that's fine. So we're going to have to work out surface area here of the whole can and then the volume. Okay, so first step, surface area of the can. So the surface area of the can is 2 lots of circles. So 2 lots of pi. R is the radius. So 3.5 squared. Like that. And then we're also going to have another one where we've got height of 9 times by the 7 pi. So the company manager asks 7 and 9. Okay, so this is a very interesting question. Right, that's the surface area of a can. Let me work that out totally. Shift pi times by 3.5 squared, and then add 63 pi. So that's 301 over 4 pi, keeping it in terms of pi, but also if I go SD, 236.404,872, and that is centimeters squared. Okay, so what am I going to do here? That's for 1. If I do that by 1,000, if I do 1,000 divided by that, Why am I doing 1,000? No. Let's get this right. Oh my God, I've almost changed screens. 100 times 100 is 10,000. So if I do 10,000 onto here, 10,000 divided by the answer, 42.3. I'm going to assume, I don't want to go over it. I'm going to assume it, right, so assume, should we say 40? We'll go with 40. We'll assume 40 tins are made per sheet. I think that's a fair assumption. So let me just put that there. So I've worked all that out. 40 tins are made per sheet. Yeah, I'm all right with that. Okay, so how many tins do we need? So, right, next assumption, assume production of soup is constant. That's my next assumption. Oh, sorry for sniffing. I think I've got hay fever. Is it fair? Is it fair that this factory is going to run out of hours? I don't think it is. I'm going to assume they do. So 12 hours, 8 to 8. That's a nice long day. People can work split shifts. So assume production is 12 hours per day. And then we'll work that out from there. So volume of the cylinder is, okay, we pi r squared times by the height. So pi, and this is r squared times by the height of 9. Let me check that's 9. Yeah, 9, lovely. 3.5 squared times by pi times by 9. So it's 346.36. That is the volume. Litres of soup, so. And that's millilitres. That's what, actually, no, it's not. Well, it's centimetres cubed. I don't have any calculations with density or anything like that. So I'm going to assume the volume. I'm assuming that's going to be able to hold. We'll say it's 3. Should we say 3 so 340 millilitres per tin. And that's therefore 0.34 per tin. Okay, we're going to assume. I'm just going to go in the middle here. For this, 2,000. That's easy. Assume 2,000 litres are produced per hour. Right. So 2,000 litres per hour divided by 0.34. 2,000 per hour, and that's divided by 0.34, so that we know how many tins we're producing. That is 5,882.35 tins. Happy with that. Okay, gonna check everything up here. Yeah, okay, that's how many tins are produced per hour. I could times that by 8. No, 12, because we said there's going to be 12 hours. So that is 70588.23529. I'm now going to times that by 7 because there are 7 days in the week. Times by 7. And that is 494,117.6471. Okay, so that is the amount of tins that are going to be produced. I can make 40 tins per sheet. So if I divide this by 40, that's going to tell me how many sheets we need, which is 12,352.94118. And then we round it to the nearest 10. So it's 1, 2, 3, 5, 0 sheets. So happy. I would be rounding that up, to be fair, but it says the nearest 10 in that question. So that was tough. That is a tough question. You've really got your head around some numbers. Explain how your answer might be affected by the assumptions. So more sheets needed if production time is longer than 12 hours. So if they work for longer, it's going to produce more, which means they're going to need more tins. Okay, I'm happy with that. I'm going to go through the mark scheme, just double check I've done anything right. I'm pretty sure I've done anything right. If you spot an error or if you've done it a different way, which there will be different ways, that's fine. Let me know in the comment section. But hopefully you found this really, really useful and you already have subscribed, spread the word. But yeah, keep up the good work and good luck for your exams. Speak to you soon. Bye-bye.